whole lot of properties of exponents today and properties of radicals. Okay? You need to make sure by tomorrow that you are dialed in on all of these. Some of them are review for you, some of them are not. I'm going to make you guys come in and take a quiz now. I thought it was because you just needed a break. You guys are such high maintenance. It says this in your book. It's written in your book. This is copied right out of your book. You need to be able to use properties of exponents and simplifying expressions. You also need to be able to do properties of radicals. So over here, these are all our properties of exponents. We've done this before, right? We have had this list of product property, power of a product, negative exponents, quotient property, the simple version, and then the power of a quotient. You've got to be able to use these properties. Now, what's different about this problem than the other stuff? Why is this one different? The exponents are rational expressions. And we know from experience that some of you, not mentioning any names, couldn't add 1/4 and 1/3 to save their lives without a calculator. If you can't, think back to the very first week of school in August when I told you your undoing in this class will not be Algebra 2. It will be pre-algebra. It will be arithmetic. You can't work with fractions? Come see me. Get help. You know how many of you came in to get help on working with fractions? Exactly none. Other things that will cause problems is not being able to factor. Some of you have felt that pain. Okay, you've gotten problems wrong simply because you can't factor. It's going to get worse as we progress. You've got to be able to add fractions. 7 to the 1/4, 7 to the 1/3, you're going to get them common denominators. 3/12 and 4/12. And when you add, you're going to get 7 to the 7/12. If your problem starts off in exponential form, your answer should be in exponential form. In other words, don't switch this to the 12th root of 7 to the 7th. Unless, for some reason, that's going to make you be able to simplify it easier. You should be able to simplify it in exponential form. That's all we're doing. So when you are following these properties, when you have rational exponents, they behave according to those properties. These are applying the same properties that you know to rational exponents. It's not rocket science. It's pre-algebra. It's arithmetic. But we know that that blue calculator that you used in 4th grade and 5th grade and 6th grade that had the fraction button, we know that that was your undoing. What are you going to do about it? Because this is a no calculator problem. Okay? Now, problem 2, problem 3, these examples are power of a product. You have options on how to handle it. Some of you are going to multiply 6 times 4 and get 24. And then add 3/6 and 2/6 and get to the 5/6 power. Why can't you do that? Why can't you multiply the 6 times the 4?
Because you have to get rid of the
Why can't you multiply 6 times 4 in this situation?
You gotta get rid of the exponents.
No. Let's go back and look at the properties real quick. Look at your properties. Look at the very first property. It's the product property. They have to be the same. Begins with B, ends in A's. Base. Very good. 6 and 4 are different bases. So you can't combine this expression in here. What we can do is we have a power of a product property, means we multiply the powers, and we're going to get 6 times 4 to the 2/3. We multiply our exponents here. 2 times a half gives you 6 to the first. 4 to the 1/3 power is going to give you 4 to the 2/3 power. Now 4 to the 2/3, we actually can take that a little bit further. And we can change the 4 to 2 squared.
I think it only square the 2/3, not 4, so. Why is it
Go back
six?
to your
Why-
property. Go back to your properties. The bases never change. If you look at your properties, your bases never change. When you have a product, power of a product, all we do is multiply the exponents. You get a to the mb to the n. Right here, a to the mn, the base doesn't change. Just the m and the n get multiplied. So when we have a product, it doesn't matter what's in there, we just multiply our exponents. Okay? The bases don't change. When you start making up your own properties, that's when we have issues. You're falling into this hole. You're getting sucked into the abyss of not paying attention. Two squared to the 2/3 power becomes 2 to the 4/3 power. If your numerator is bigger than the denominator in a power, it means you can separate them. You can simplify. 2 to the 3/3 and 2 to the 1/3. What's 2 to the 3/3?
1, 2.
2.
Yes.
Yes, sir?
For
Me?
No.
Okay. So what does 3/3 become?
1.
And 2 to the first is just going to be 6 times 2 is going to be
If the numerator
6 times, hang on, 6 times 2, 12 times 2 to the 1/3. When?
if the numerator is bigger than the denominator,
Right here. Numerator of an exponent
Yeah.
is bigger than the denominator. That means you have a power more than 1.
okay.
Okay? If you have a power less than 1, like a third, you're done. As long as the base can't be simplified,
I thought
like
you
here.
said multiply if the base was the same.
Well, this is 6 times 2. We're not doing powers. It's not 6 to the 3rd times, that's not what we have. You can't do it then.
Oh, because 3 over 3 is 4. Okay.
Right. Okay? So, go ahead.
So it becomes 12 times 2?
Yes? 2 to the 3/3 is 2, right?
Yeah.
And 6 times 2 is 12, right?
So why don't you just do 12 times 2?
That's exactly what I wrote.
Yeah, but can you just multiply so you get 24? No.
This is 12 to the first times 2 to the 1/3. They're different bases. You're making, and this is the danger of all of this. You've got to know these properties. Kinda, sorta, maybe means you're going to kind of suck a lot. Okay? You've got to know these properties. Bam, down, got it. Because it's going to get harder. You've got to know these properties. Now, we really don't want to put that one in. Just keep it like this. Now, I don't really like this as an answer. And this is a personal deal. I don't like it when you're multiplying a constant times a constant to a fractional exponent. I think that we should be writing this like that. 2 to the 1/3 is the cube root of 2. 12 cube roots of 2. That makes much more sense to me. It's much cleaner. But when you look in the book, a lot of times they're going to leave it in this form.
Will we get answer wrong if we write it that way? Or can it be?
I think I would be okay with this, but here's the rule. Start in exponents, end in exponents. If you follow that rule, you're never going to make a careless mistake. You're not going to be in a form you don't want to be. Because this rule doesn't apply to every single problem that we're doing. Right? So examples 4 and 5. Now, in this problem on the left, what's different about this than the last problem? Well, yes, it is division. That's a good observation. The bases in this problem are the same. What we may or may not realize is that we can simplify using which property? Yeah, I never said the division property. What is this? Mitosis? Meiosis? What is it?
Innovation.
Yeah, but I don't call it the division property. The quotient property. So what are we going to get? Maybe I'm not doing this emphatically enough.
Negative 2/3.
Five,
Negative 2/3.
five, 6, 7.
So what do we get?
5. No, it's like
5 is negative.
5 and 2/3? 5 to the power of 2/3.
There are 36 properties.
I did. What did you do?
1 minus
1/3 is 2/3, right? Power on the top is 1. It's bigger than the one on the bottom. 1 minus 1/3 is 2/3. The bases don't change, ever.
Oh, wait.
The bases,
Ignore me.
I can't help it. The bases are the same, so we subtract our exponents and the base stays the same. So this is 5 to the 2/3. It isn't 1 minus 1, it's 1 minus 1/3. 3 over 3 minus 1 over 3 is 2 over 3. Is that what you're asking? Okay. You sure? Okay. Folks, this problem on a scale of 1 to 10 is a 0.5 level of difficulty. This is easy. You have to know these properties. You think that you know them, but I get people who want to cancel the 5s and put 1 to the whatever power. You can't kind of know the properties. What's wrong with this one? Now you have different bases, so what the heck? But what you do have in this problem that you can utilize is that your powers are the same. If the powers are the same, then we could do 42 over 6 to the 1/3, and all of that would be squared. Because this power is the same, we can do the reverse of the power of a quotient property. Here, up here, they've cast out the 1/3 to the top and the bottom. But what is 42 over 6? 7. We love that. Because now we don't have to deal with that fraction anymore. We have 7, and then what do we do with those powers? Multiply. 7 to the 2/3 power. Is it not? Is what not? Is divided. If it's a quotient, absolutely. But what you need to be aware of is that because these powers are the same, this is the next line. That's the reverse of the quotient, power of a quotient property. Look back at this property list. So see, here's what we were given. We were given the right. A to the m over b to the m. What I'm saying is you can go back to the beginning and do a over b all raised to the m power, but only when the powers are the same. You're absolutely right. Well, again, so you're telling me you want to skip doing that step. My question would be, why do you want to skip that step? Then show me. Because I want to know how you got there. And I'm not going to be able to see that process without you showing me. Okay? So 7 to the 2/3. We start with an exponent, we end an exponent. Can't rewrite the 7, and 2/3 is reduced and it's not more than 1, we're good. All right? you can see we're getting a little more complicated. Try to simplify these on your own. Okay, so apparently B is easier. Bases are the same. What do you do with your exponents? Add them. So 2 to the 3/4 times 2 to the 2/4 is 2 to the 5/4. Now again, this would be another example where I would say you're better off in radicals for this. When the numerator is bigger than the denominator, it's just easier to work in radicals. But if you'd rather stay in powers, it would be 4/4 and 1/4. What's 2 to the 4/4? 2. And then times 2 to the 1/4. Which again, I think that's just kind of silly. So I would be better off doing the 4th root of 2. So when the top of your exponent is bigger than the bottom, the rational exponent is more than 1, we can make this the 4th root of 2 to the 5th. And then we can do good guys, 2 to the 4th, bad guy, 2 to the 1st. The 4th root of 2 to the 4th is 2 times the 4th root of 2. Yes, dear?
Could we do like 3/4 over 2/4?
No what? I didn't understand your question. Help me out here. What? What?
Because you wrote 4/4 and then 1/4, which is 5.
Well, 4/4 is 2 to the 1st. And you wanted to do something different?
Well, I'm just saying.
What did you want to be?
Never mind.
3/4 and 2/4? That's what we started with. Doesn't help us. No? Okay.
Okay. How did you get 2 for
6/8, who do we appreciate?
yeah,
How did I get?
2 root 4
I don't have 2 root 4 anywhere on
2
here.
4 2. I don't know how to say it.
You need to.
2 root 4
Right here,
yeah.
this is the 4th root of 2. 2 times that. What's 2 to the 1st? 2. 2 to the 1/4, I'm going from exponential to radical.
So how do you do that?
This is a different process. So once you get to here, you can go here.
Yeah,
The 4 is your index.
yeah,
The 5 is your power.
yeah, I got that.
You just said to me, how do you get
No,
that?
but I don't know how you got
Didn't he just say
the second step.
5 is more than 4, right?
Yeah,
So we can take out a good guy of the 4th root of 2 to the 4th.
after you take out.
Remember when we did the square root of 8 is the square root of 4 times the square root of 2?
Yeah.
And the square root of 4 is 2, right?
Yeah.
We're doing the 4th root of 2 to the 5th. Good guys are multiples of 4. 2 to the 4th is a perfect 4th root, right? The 4th root of 2 to the 4th is 2. If you take 2 to the 4th in the good guy pile, and then you started with the 2 to the 5th, look at me,
Okay,
you have 2 to the 1st in the bad guy pile.
okay,
That's left over, 4th root of 2.
okay. The 4th root is 32.
The 4th root of,
32. Yes.
but the 4th root of 32, you would have to simplify to the 4th root of 16 and the 4th root of 2. The 4th root of 16 is 2, times the 4th root of 2. But yeah, 2 to the 5th is 32. If you'd rather take that path, there's a third path. So, awesome. Whatever you see is fine. Just show your work. That's where I get uncomfortable when you don't want to show me your work.
Say that if they gave it to us in the fractional form, we can't give it back.
Well, like I said, if your answer gets to a point where you have a number times a number to a power, that just seems silly to me, and I'm fine with you switching it to radicals. That makes more sense. Okay? 5 to the 1/3, 7 to the 1/4. All to the third. We're going to use this power of a product property. This becomes 5 to the 3/3 times 7 to the 3/4. And again, that would be a fine answer to have. For me, because I have a number times a number to a power, I tend to want to do 5 times the 4th root, 7 cubed. But that's a personal choice.
If you write it that way in the first place,
I don't know, ask Tyler. Yes, he does. He just didn't hear her question. Ask him. Yes,
Oh my
and
God.
he's going to answer it for you.
Will we get marks out?
Good? Yeah. Try this one. We did both of these? All right. Properties of radicals work the same as properties of exponents because a radical is an exponent. So you have the nth root of a product, we can separate into the nth root of A, nth root of B. Have we done these before? Have we had these in class yet? Okay, so this is the product property for radicals. So the nth root of a product, you can separate it into the nth root of A and the nth root of B. The same thing is true for quotients. The nth root of a quotient, you can do the nth root of A over the nth root of B. Works in both directions, so I have the cube root times the cube root. If we multiply 12 and 18, what do you get? 2 what? I just didn't hear you. 216. 216. Cube root of 216 is what? You got to start recognizing, even though this is a little bit out of bounds, you should start studying. I know that half of you or more did not study powers of 2 last night. Your perfect squares 1 to 15 and your perfect cubes from 1 to 5. And I know what's going to happen. I showed you the results that are coming your way. Starting off with a D or an F in this second half of this course means you have to play catch up the whole the whole rest of the 10 weeks. You need to study. You have a day off tomorrow. That means you just don't have to come here. You have work to do. Do it. Just do it. Now here you have the quotient already separated. We want to go backwards just like we did with the powers. What's 80 over 5? 16. You need to do this without a calculator. What's the 4th root of 16? 2. That's a power of 2. You're supposed to memorize them. No. No. You need to memorize your powers of 2. You need to know your perfect squares. You need to know your perfect cubes. If you don't do that, you're going to be at such a disadvantage. It's going to be very painful for you, and you will have a very hard time recovering. Mr. Lockery is so mean. He tells us we're going to fail. That's not what I'm telling you. You're not going to fail if you prepare. If you choose not to prepare, it's going to be pain and suffering. And you aren't going to recover for a long time. And those of you who have to get the A in your world, if you start off with a D or an F, it's hard to do that. Questions on these? Start participating. Start asking your questions. Okay, this is good guys, bad guys. Now, you probably learned some version of this when you were in Algebra 1, simplifying radicals. But you probably, at least when I taught it, I only did square roots. I didn't try, because the higher the index, the harder it is to do good guys, bad guys. good guys, bad guys is this property right here. You have the nth root of something, separate it to the nth root of A times the nth root of B, but make sure you pick a perfect nth factor on the left. That's my good guy. So the cube root of 135. What I'm looking for is two numbers that multiply to give you 135. Why are you making that face at me?
45 and 30.
I need to get a camera so I can have pictures of that face. Like, what the hell is he talking about?
45 and 30.
45 and 3. Which of those is a perfect cube?
Oh.
Neither of them. So you pick two bad guys, which is fine, but we need good guys. 27 and 5. Good guy, 27. Bad guy, 5. How are you going to know the good guys? You memorize them. But not perfect squares.
Cubic squares.
What did you mean?
I meant what you said.
Yeah, what did I say?
Wait,
Good guys and
Look at the question. What do we want? Not perfect squares, perfect cubes. Yeah, I wanted you to physically say it. So the cube root of 27 is 3. Times the cube root of 5, that's your bad guy. Good guys, bad guys. All right? Quotient property here. Now, the problem with this, just like when we did it with the exponents, the problem with this is that you have a radical in the bottom. When you go to simplest radical form, there can be no radicals in the denominator. All right? You have a fifth root of 8 in the denominator. The fifth root of 7 in the top, you're fine. You can't simplify anymore. But you cannot leave this radical in the bottom. Now, tell me another way to write 8. Okay, another way. Another way.
2 cubes.
2 what? 2 to the third power. You probably did, but there's a lot of people talking. What can I do to a fraction that will not change its value? By 1. The only thing you can multiply by without changing value is 1. So we're going to multiply this fraction by 1, but we're going to do it in such a way that the bottom becomes a perfect fifth. I'm close to being a perfect fifth. How many more 2's do I need? 2. So I'm going to multiply by the fifth root of 2 squared over the fifth root of 2 squared. That way on the bottom, I'm going to get the fifth root of 2 to the fifth. Whoops. So I'm going to have the fifth root on the top, the fifth root of 7 times 2 squared, which is 28. And on the bottom, I'm going to have the fifth root of 2 to the fifth. What is the fifth root of 2 to the fifth? 2. If you multiply these together, we add those powers, and the fifth root of 2 to the fifth leaves me with the fifth root of 28 over 2. You know what I'm going to get from some of you for answers? What do you think I'm going to get as another line? The fifth root of 14. Right? Try these 4. Again, more than one way to do this, but you want to do the fourth root of 81. Now, everybody should be able to multiply 3 and 27, but the fourth root of 81, you may or may not know. You may need to treat it, but the answer is 3. Let me show you another option. What's another way to write 27? Question.
9 and 3 cubed.
3 cubed. So if I wrote it as the fourth root of 3 cubed times the fourth root of 3, that becomes the fourth root of 3 to the fourth. And the fourth root of 3 to the fourth, 3 to the first. What you're doing here is you're dividing the power by the index, 4 divided by 4, to get 3 to the first. That's switching from radicals to exponential. Okay, so you have options. What should we do here? Quotient property. So you get, in the cube root of 125, 5. If you're not seeing it, you've got to get your hand up and ask. Andy, which part? To here or to here? From here to here?
Yeah.
So from here to here, we're doing the reverse of the quotient property.
Right.
Technically, it would be this. And I didn't write this.
Oh, that's weird.
And 250 over 2 gives you the 125. And the reason why we can do that is because they're both cube roots, and it's the end of that quotient property. So you have the root of a quotient becomes the quotient of two individual roots. And we're just going backwards.
Yeah, 'cause I was trying to.
Separate them out.
Yeah.
Yeah. And you could do that. You could do good guys, bad guys for the 250 and do 125 and 2, and you get 5 times the cube root of 2 over the cube root of 2, and they would cancel. That's another way. So your instinct is good. Got to finish her off though. Okay? The fifth root of 3 over 4 is the fifth root of 3 over the fifth root of 2 squared. Easier to be smallest base to a power. Now, what can I multiply by? Only can multiply by 1. And we're going to do the fifth root of 2 cubed. Fifth root of 2 cubed is going to give you the fifth root of 8 times 3 is 24. Over the fifth root of 2 to the fifth, which you don't need to show that line. I'm fine with you just saying it's 2. The fifth root of 24 over 2. And there's no perfect fifths in 24, so we leave it like that.
That's not multiplied by 1.
What did I multiply by?
Oh, no, you're right, never mind.
It doesn't matter what it looks like, as long as it's equal to 1. This is equal to 1. Right here, that's a 1. Okay? And then the cube root of 5 plus the cube root of 40, it looks like we're done. There's nothing we can do. They're different animals. We got a giraffe and a hippo. You can't add those together.
Those are awesome.
The cube root of 5, nothing we can do with that. The cube root of 40, what's the good guy? 4 is not a good guy. We're doing cube roots. 9 is not a good guy.
8.
8. And bad guy? 5. 9 doesn't go into 40 anyway. Just for the record. And the cube root of 8 is?
2.
The cube root of 5 plus 2 cube roots of 5 is?
What? It's not cube root of 5.
This is the cube root of 5 plus 2 cube
Oh,
roots of 5.
3 cube root of 5.
3 cube roots of 5. Can you believe it? Poor Nelson. Do you have a girl that keeps you up at night, or what's going on, dude? You gotta get you some extra rest. Ask your question. Is you going like that? You sure?
The human body's temperature drops
Here we
the
go.
same way that it does at night once you're ready to go to bed, right around like this time, like between 1:30.
So I can expect to cool off?
Yeah, that's just why people get tired, like as they're getting like ready to nap around this time.
No more napping.
It's a natural
Yep,
sleep
blame it on
cycle.
nature.
It doesn't work for me.
I know.
My temperature does not drop, and I do not nap. I cannot nap.
I can't.
Look it. When you are dealing with radicals, radicals are like variables. They have to be the same index, same radicand in order to be considered like radicals. And I don't mean like radicals, oh my God. I mean like meaning similar, meaning things that we can combine. Fourth root, we can combine them. Yeah. Fourth root, cube root, not the same index. We can't deal with them. It doesn't matter that the radicands are the same. If they're different indexes, no way. They have to be same index, same radicand in order to be combinable or like terms. You also have to be in simplest radical form. So are these like terms?
Yeah.
Yeah. Fourth root of 10 and more fourth roots of 10. How many do we have here?
1.
1. When you combine them,
8, 40.
fourth roots 10. Make sure that that 4 is in the V. I have had students in the past that are floaters. They float the 4 and it ends up looking like this. Or they do this little check mark. What the heck is that? And they float a 4 there. What, 84 root 10? You want this sucker in the V.
I do like a little platform thing.
That's what I do.
The platform
Because
thing.
that's how it's written. Yeah. I think we should do it.
I'm used to being wrong. I'm a male. We're always wrong. You're a female. You're never wrong. So we don't have any problems with this. I know my place. Now, I don't know anything about this platform. Hang on. Yeah, that's going to get marked down. Okay, she's giving me this thing here. And floating the 4 above the platform. Thank you for playing. We have some lovely parting gifts for you. You can platform all you want.
It's probably going to in here and still be able to read it.
Okay. Don't care. What I don't want is a floating 4. I want the 4 in the V. It's what? Yes, it is.
It's easy,
Want to bet? What do you want to bet? You're looking at your calculator for advice? Seriously?
Yeah, look at mine.
Oh my god,
Oh my God, look, it's written wrong on my calculator. I'm just telling you.
You're so
The index goes in the V. I am not wrong on this one.
it's your platform.
Thank you so much. I'm sure that I'm wrong, but I'm going to mark you down if you don't write it wrong.
Okay, that's
All right? We good with that? Well, I know, but are you understanding why you're going to get marked down? Because I'm being like your dad. I said so.
Yes.
So no real reason other than I said so. Okay? Now, I personally don't like this mess because we have numbers and bases to powers. Huh? So for me, I would say make this 2 times the 5th root of 8 plus 10 times the 5th root of 8. What does that give us? 12 5th roots of 8. Notice the 5 in the V, not jumping off the platform. Uh-oh. Problem C, we can't do this one. Why? Different radicands. Not close enough. We need them to be the same, not kind of like each other. So what do? Circle it, or good guys, bad guys? Who's the good guy for 54?
27.
27, bad guy?
2.
2. So this is 3
Do the math.
cube roots of 2 minus the cube root of 2. You know what some people are going to tell me? The answer is 3.
4.
Wait,
It's 2.
2 cube roots of 2. When you go like this, not helping,
Okay, the one right below the
Yes?
Why are they like squished together?
This is the cube root of 54
Oh,
is a product,
okay. See, that's just.
totally my fault. I just wasn't paying attention. I'm so sorry. Oh my God, I can't see everything you do. Good or not good? Holding on. Yes, seriously. Oh no.
Met.
See this? Are you looking at this? In the V, not in the platform?
That's on the platform. It's just weird.
Floating? I don't even have a radical now.
They're not floating on.
We're not floating them.
On the green, they're not floating.
They need to be in the V.
Well, technically, I never
Because
seen
then
it
they look
floating.
like they end up.
Technically.
This one?
Not in the V. I'm sorry.
Put it down here. Let's not start arguing over here.
Right.
I just want to know.
I want it plugged
It's
around
slightly
here.
closer to the platform.
Pull
I'm
this
sorry.
smaller.
There you go. You got it correct now.
Okay, you do it any way you want, but if it's not in the V, it's -1. I'll leave it up to you. So x to the 9th, you could take out a good guy of x to the 4th. Or x to the 2nd. I said you could. This is a square root. X squared is a perfect square. So is x to the 4th, so is x to the 6th. So you have options with x to the 9th. If you did x to the 9th, the square root of x to the 9th, and you did the square root of x to the 6th, what would the bad guy be? If I chose to do the square root of x to the 6th, the bad guy would be x to the 3rd. Some of you are sitting here thinking right now, wait a minute, wasn't x to the 9th a perfect square? The square root of x to the 9th is x to the 3rd, right? Some of you are thinking it. You don't have to tell me who you were, but I know some of you were thinking it. It is not the square root of the power. All right? X to the 3rd times x to the 3rd is x to the, not x to the 9th. So it is not a perfect square. If you chose to do x to the 6th times x to the 3rd, that's okay. X to the 6th is a perfect square. What is the square root of x to the 6th? X to the 3rd. All you have to do is take 6 divided by the imaginary 2. That's how you get 3. And you have a square root of x to the 3rd, which is great, but it's not simplified.
Why are you doing the square root of x to the 6th?
I did.
I mean, why don't you take the square root of the power of 6?
Because you don't do it that. You're not taking the square root of power, you're taking the square root of x to the 6th.
Since the square root is technically a power, that's why you did that.
The definition of a square root is something times itself will equal the radicand. Okay? X to the 3rd times x to the 3rd is equal to, therefore, x to the 3rd is considered the square root of x to the 6th. If you think about it in terms of radical versus exponential, remember this would be x to the 6 over 2 power, right? Which is x to the 3rd. You divide the power by the index. That's why we always want good guys that are multiples of the index. In this case, a 2. Yes, sir.
Can we just, is it okay if we had like x to 4, 4 and a half?
That's a fractional exponent. That's not acceptable. We're simplifying radicals. That means you can't have any perfect square factors under the radicand. It's not a matter of just taking and making this x to the 4.5 power, 9 over 2. That's true, but you're writing it exponentially. I need you to write it radically in simplest radical form. So no perfect square roots under the radical. Now x to the 8th is the biggest perfect square. It's the biggest multiple of 2 that's less than 9. That's why I want to go x to the 8th and x.
So that's the right answer, but also.
I'm not finished with the other one. This is the square root of x to the 8 is x to the 4th root x. If you decided and saw x to the 6th first, that's fine. You get x to the 3rd times the cube root of x to the 3rd. You have to continue good guys and bad guys. Who's the good guy factor of x cubed?
X to the second.
X to the 2nd and x to the 1st. What's the square root of x squared?
X.
X. So you'd have x cubed times x times the square root of x.
So X to the 4th times.
And that's your x to the 4th root x. I'm not recommending that, but sometimes you just can't help yourself.
So, did you
We can get along with this stuff.
the square root of x to the third? Like for the 1/4 line up. X to the third.
Square root of x to the 3rd.
Okay.
And the square root of x to the 3rd is good guys, bad guys. And the square root of x squared is x. And then x to the 3rd times x to the 4th. Case?
Oh, I'm good.
Okay. So,
Basically, you just divide ways between the third.
well, again, this isn't always going to be a 2. It could be a 3 or 4 or 5 or 6. You need a multiple of the index. Multiple of 2. The biggest multiple of 2 that's less than 9. So again, the square root of x to the 16, big mistake is to say it's x to the 4th. It's not. It's x to the 8th. Correct. Oh yeah, I would never do that. Close. Sorry, we're doing it on Thursday.
Yeah, why do we
Really what? Because you have a day off. Actually, this homework assignment, the first one, should not take you very long. It will take some of you days to do because you haven't learned your properties, don't know your powers of 2, don't know your square roots, and don't know your cube roots. So it's going to be painful. Okay? For A, let's do good guys, bad guys. Cube root, cube root. 64. I need a perfect cube that goes into 64.
64.
64, very good. And a perfect cube that's a factor of y to the 6th. They're both good guys. So we don't need to do good guys, bad guys. They're both good guys. What's the cube root of 64? 4. Cube root of y to the 6th?
Why did Or no, yeah.
Why did the second?
Why did the third? Oh, you're right, 2 times 10.
6 divided by 3, 2.
Oh.
Right?
Yes.
I don't want you to make this mistake, so I'm not even going to show you the mistake till after we do it correctly. This is a product to a power. What does the property tell us to do in this situation? Multiply your powers. That means we're going to go 27 to the 1/3, p to the 1st, q to the 4th. What's another way to write 27?
3 to the 3rd.
3 to the 3rd, to the 1/3,
3.
p, q to the 4th. What's 3 to the 3rd to the 1/3? 3. P, q to the 4th. More than 50% of Algebra 2 students at this point in time would not have had a power of 1/3 right here. That would have been omitted. They would have got 27 PQ to the 4th. More than 50%. Even on the first quiz, more than 50% will make that mistake. Don't get into that boat. If it's in the parentheses, it gets the power on the outside, even if it's a constant. How about C? What do we deal with?
Root, then I
Oh, did you see what that did?
4th root of n to the 4th.
The 4th? fourth root of m to the fourth, and the fourth root of m to the fourth is, well, you might guess, m over
And
to the second.
Oh, yeah, I was like, oh, those seem to be different.
Did I make a mistake?
No.
Okay, so then the last one that I'm going to do today, 14 divided by 2. So we simplify, we get a 7. X over x to the 3/4.
1/4, excellent.
X to the 1/4. Z to the 1, or sorry, y to the 1/3. There's no y's here, so it's just going to be y to the 1/3. Z to the 6. Y is, because it was all out, no. Oh, really?
So,
This is so what? Fun, that's the right word.
fun.
Good F word. It's not the best F word, but it's a good F word.
Not using the S word.
Now. Yeah, it's not you, Mike. Listen. 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 It works better without talk game. 6-2. This is tonight's homework right here. This is Thursday night's homework. You really need to make sure